The 19th century British scientist Lord Kelvin first developed and proposed the scale. It was often called the absolute Celsius scale in the early 20th century. The Kelvin was formally added to the International System of Units in 1954, defining 273.16 Kelvin to be the triple point of water. The Celsius, Fahrenheit, this definition by itself is not sufficient. However, modern absolute scale. Thomson specified that the scale should have two properties. 1. The absolute values of two temperatures are to one another in the proportion of the heat taken into the heat rejected in a perfect thermodynamic engine, working with a source and refrigerator at the higher and lower of the temperatures respectively. 2. The difference of temperatures between the freezing and boiling points of water under standard atmospheric pressure shall be called 100 degrees, the same increment as the Celsius scale. Thomson's best estimates at the time were that the temperature of freezing water was 273.7 Kelvin, and the temperature of boiling water was 373.7 Kelvin. These two properties would be featured in all future versions of the Kelvin scale, although it was not yet known by that name. In the early decades of the 20th century, the Kelvin scale was often called the absolute Celsius scale, indicating Celsius degrees counted from absolute zero rather than the freezing point of water, and using the same symbol for regular Celsius degrees, degree Celsius.
How does heat transfer from hot to cold? And unless people interfere, thermal energy, or heat, naturally flows in one direction only, from hot toward cold. Heat moves naturally by any of three means. The processes are known as conduction, convection, and radiation. Sometimes more than one may occur at the same time. When hot water comes into contact with cold water, heat flows from the hotter water to the colder water until they reach thermal equilibrium, the same temperature. 2. Conservation of energy. The total amount of heat in the system remains constant. The heat lost by the hot water is equal to the heat gained by the cold water. 3. Formula. The equation M hot times C times open parenthesis T final minus T hot, close parenthesis equals M cold times C times open parenthesis T final minus T cold close parenthesis represents this principle. By substituting the known values and solving for T final, you can determine the final temperature of the water mixture. Example. Let's say you have 100 grams of hot water at 90 degrees Celsius and 100 grams of cold water at 20 degrees Celsius.